really very well planned. It has covered almost all the areas of research. And today topic, that is of sampling designs. And we all know that everything changes but the change. That in in our lives there is continuous change, and research, that is the main reason, main background behind the changes. And research that is based on accurate and reliable data. uh, Research that is further used in many processes, that is in policy formulation, in planning, and in many other aspects. And for all these, first step is data collection. And data collection, if there will be accurate data, there will be reliable data, only then further research is possible, and only then you can reach to, you can conclude with effective policy formulations. So data collection, that has a very, that is basis, no doubt basis of research, but even though it has a very important pertinent space in the research. Now, starting with sampling designs, first of all, I will like to go through what are the various ways of data collection. I am starting presentation. Just a minute. Whether presentation is visible?
Yes, madam.
Whether screen is visible?
Yes,
okay.
madam. Thank you.
Okay. There are various ways of data collection. Basically, we opt two ways. One is the census method, and another one is sample method. What is census method? When you study each and every unit in the population, what is the population? It is the any number of respondents which are related to your inquiry, which are related to your topic. If you study each and every unit of the population, then it is census method. And
Excuse
definitely,
madam, PPT is not visible, madam. Just it is
PPT
blank.
is not visible.
It is blank, madam. Now it is coming, madam. Yes.
It is okay.
Now it is
Visible?
coming. Yeah. Now it is.
Okay.
Now it's coming.
Okay. Okay. When we study each and every unit of population, then it is population under study. That is population related to your query. Then it is called as census method. And what are the various merits of census method, or where we use census method? When the population is heterogeneous. That is, heterogeneous means different respondents have different characteristics. They have their own unique characteristics. They are not similar to each other. And when we need very reliable and accurate results, no doubt, then we use census method. But still, in census method, there are other types of limitations, that non-sampling errors increase, administrative control increase, even though it may lead to non-reliable results or non-accurate results. But there are merits, but there are also demerits, that it requires a lot of time, labor, finance, because you have to study each and every unit. So resources must be abundant in this case. And in case of destructive population, you can't use census method. What is destructive population? Which when we use it, it destroy. Suppose I have to. It's a very good example. Suppose I have to test the blood group of a person, and if I take whole blood of that person, then what will happen? Person will die. It is a destructive population. Similarly, suppose there is a matchbox, and I have to test whether the mastics in matchbox, they are effective, they are working properly or not. If I try all the mastics, if I strike all the mastics, then it will totally destroy. And if it will, mastics will be totally exhausted, matchbox will be totally exhausted, then that means I will be left with nothing. I can't use then census method. I have to use sampling method in that case. If there is infinite population, that there are countless number of respondents. even though it's difficult to study each and every unit, then I have to use sample method. Now coming to sample method, in sample method, few units are drawn from the population or universe for the study. And no doubt it requires a lot of time. It requires lesser time, labor and finance as compared to census method. And obviously, which are the merits of census method? That will be demerits of sampling method. And which are the merits of demerits of census method? That will be the merits of sampling method. Like it can be used in destructive and infinite population. The results will be here also results can be reliable and accurate if sampling technique is done by skilled person and it is done with the proper scientific way. Then there are also demerits that in case of heterogeneous population, it may not give good results. Then it requires skilled and trained personas. Obviously, if you have to use sample method, then you can't choose any person in your sample. You have to choose through a technique, through a scientific technique. So it requires a lot of skills and trained personals for drawing a sample. It is some points of comparison of sample and census method. Suppose you have to choose census method, or whether you have to choose census method or sample method, that depends on number of factors. First factor is resources available. I have already explained. If their resources will be abundant, then we can use census method. And if resources are small, less in number, then we can use sample method. Suppose you have a lot of time, then you can easily survey each and every unit. But if you have lesser time, then you have to choose sample method. Similarly, if you have abundant finance, you have abundance of money with you to conduct a research, then you can
Madam,
use.
Sorry, madam, for interruption. PPT.
Yes, sir.
Yes, PPT data is not visible, madam.
So
PPT
data is not visible.
Yeah, now it's coming, madam. I think. Yeah, now
it is visible. Sir, is it visible?
Yeah, now it came, madam.
Okay, sir. From my side, the settings are same. I think yes, there is some other issue or network issue.
Yes, madam.
Okay, I will set it side by side on my laptop also.
Yes, madam, please.
Okay.
Now it is visible, madam.
Okay, okay. Sir, then next is population size. If size of population is large, then it is difficult to study each and every unit. Then we have to use sample method. But if size of population is small, then we can use sample method. Because, size of population is small, then we can use census method. Because it is easy to use each and every, to survey each and every unit. Then again, next point is variance in data. Variance in data is if there are large variance in data, that is all the units, they are not similar. They have a lot of variance in their characteristics. If I take example, suppose I have to collect the data of students from a class and marks are like that. One student has 10 marks and another one has 90 marks out of 100. And some have 60, some have 70, some have 80. That means variations are large. Then we must opt census method because sample may not be true representative in that case. But if variances are small, that is all the units are around same average value, that one has value 58, then another student has marks 59, then 60, 61, 62. That means marks are almost same. Then we can use sample method because sample will be true representative in that case. Then destructive and non-destructive I have already explained. And if cost of sampling error is high, what is sampling error? It is basically selecting a wrong technique of sampling. If it is high, then we use census method. Otherwise, we use sample method. Then cost of non-sampling error. Non-sampling error, that can be of any other type. I will explain it in this lecture later on. And cost of sampling error, if it is low, then we use census method. And if it is high, then we use sample method. If we want to give personal attention to respondents, then we use sample method, because number of respondents will be less and we can easily give attention to each and everybody. But if we don't want to give personal attention to each and everyone, then we can use census method. Now, these are the certain concepts.
Screen is blank. Yes. Screen is blank actually.
Again blank?
Now it's okay. Now okay.
Okay.
Now it's okay. Okay.
It is okay?
Yes, madam. Now it's okay.
Okay. Sir, actually, I think when I move to another slide, then for a fraction of second, it is black.
Okay, madam.
It may be. We will, when we will go to next slide, we will again look at that. We will suppose we will go through these concepts, and this is also the process of drawing sample. First of all, we will talk about universe. What is universe? It is theoretical targeted population. What does theoretical targeted population means? Which is concept based, which is conceptual. Suppose I have to draw a sample of students of Karnataka. Now, if I draw a sample of students of Karnataka, then first I must know that how many students are there, and suppose I simplify it. Suppose I have to select a sample of MBA students of Karnataka. Then first of all, I have to search that how many MBA colleges are there, how many students are there, and how can I get the data that how many students are there. I can take the intake capacity of each and every college. Suppose there are 10 colleges and 100 is the intake capacity of each and every college. Then universe will be 10 colleges multiplied by 100 students per college. It will be 1000. It will be of 1000 respondents. Finite universe. Then what is population? It is empirical target population. What does empirical target population means? As I already told, there are 10 colleges, MBA colleges, and 100 is the intake capacity. That is the seats prescribed to them, seats given to them, and total universe was of 1000 respondents. And suppose all the 100 seats per college, they are not filled. In some colleges, it is filled like 90. In some colleges, 80, 85, or maybe in one of the colleges, it is 50 only. Then if I add all these respondents which are actually enrolled in MBA, then this is my empirical target population. Clear? Clear?
Yes, ma'am.
I would like that this session should be not only teaching, it should be interactive, so that we can learn more. If the session will be interactive, then we can definitely grasp more knowledge, and maybe I may learn from you people also. Clear? Should I continue?
Yes, ma'am.
Yes, ma'am. It's clear, ma'am.
Okay. Population can be finite or infinite. Finite if it is number is countable, infinite if number is not countable. Now, what is sampling frame? Sampling frame, when unique address is given to each and every respondent. Like in, if I am talking about colleges, then in the office there must be a record of each and every respondent. And this record, this list, that is called as sampling frame. Maybe unique ID, it is of roll numbers. If I talk about income taxpayers, then it is PAN card. Similarly, this is Aadhaar number. This is also a unique identity. And if that is listing of all the respondents, that is sampling frame. And from that sampling frame, we draw sample. It is firstly, that sample is drawn through various techniques, which I will elaborate further. And when I draw a sample, this will be my original sample. This will not be the final sample, because all the respondents may not respond. If I give questionnaire to, let it be 500 students, then it is possible that there is some non-response, that all the 500 students will not return back questionnaire to me. And if I remove that non-respondents, then I will get my final sample. So we generally try to, when we finalize our sample size, we generally try to try that it should be little bit more than what actually required is, because there must be some non-response, that non-respondents may be there. Clear?
Yes, ma'am.
Then coming to next step, that is what is sampling. Slide is visible?
Ma'am, again is not visible.
Now visible or not?
No, ma'am.
The
Not
slide
visible.
is there. Slide is there. Blank.
That
It's blank.
it is blank, madam. It is just blank.
It
You
is
have to
black
refresh.
or
Blank.
Blank.
then it happens when I move to next slide.
Yes, madam.
I
Now
switch
it's
over-
Now it's okay. Now it's okay.
Now it is okay. Na?
Now it
When
is
I
okay.
switch over to next slide, then there is, I think for a moment, it
some
turns
10
black.
seconds we need to hold, madam.
I
Yeah.
think it
Okay,
takes around 10 seconds. So I think it's okay. We wait for 10 seconds and then.
Pardon?
I think it takes around 10 seconds, ma'am. So
Yes. I think when I switch over to next slide.
yes, that's right.
Some time. Okay. Then what is sampling? Sampling is a process of selecting observations or units to provide adequate description or inferences about the population. That means it is clear from the slide. It is visible now?
Yes, madam. It is visible, madam.
Okay. From population, through sampling process, we draw a sample. And what does that sample do? Or what is the purpose? What is the objective behind drawing that sample? That is to infer regarding the population. So, like I have told you that I take a sample of MBA students of Karnataka. What's the objective behind drawing that sample? I want to judge whether the MBA students in Karnataka, they have high IQ levels, and I define it that high IQ levels are IQ levels above 8 out of 10. If by drawing a sample of 50 students, I apply various techniques, I infer that whether from that very population I can conclude that all the MBA students of Karnataka, they have high IQ level or not. That is sampling process. I draw sample to infer regarding the population. And this sample, it must be true representative of population. And it is a subset of population. This is true representative. Slide is visible?
Yes, ma'am.
Okay. It is true representative. That is sample, that is subset of population. If it is a homogeneous population, then it is truly representative. But if it is a heterogeneous population, then there are other techniques, and if it is a subset, then it can truly represent population, even though it is a heterogeneous population, if proper sampling technique is applied. But coming to next slide, if it is like this, sample is not the proper subset of population. Sample is subset of population, some of the units that I have drawn for population, but it is not the proper subset of population, then it may not truly represent population. In first slide, sample was a good sample, but in this slide, it is not so good. And in next slide, if I talk about this sample, it is totally out of population. Slide is visible?
Yes, madam. It is visible, madam.
Yes, ma'am, it is visible.
It is totally out of sample. So it is not true representative at all. It is not subset of population. It is bad sample if I go by scientific technique. Now, coming to sampling design process, how we design a sample, how we do sampling designs. First of all, as I already told.
Madam, it is in animation style.
It is.
So, animation style, you have to press again. Then the words will come. Now it's blank. Again, if you press, then the words will come.
Sir, it is
Yeah.
blank.
Yeah, it's blank. Now it's coming. Okay. I think that
Okay.
twice you have to do that. Twice you have to do.
Now
Okay.
it is visible.
Visible. Okay.
Okay. Sir, sampling design process. In this, we have to first define the population. I already told you what the population is. Then we define the sampling frame. Population, that is the each and every respondent related to your query. Suppose I have to study the COVID patients, then all the COVID patients in Punjab, then all the COVID patients in Punjab, this is my population. Then I will determine the sampling frame. Sampling frame is the complete listing of all the units, all the respondents, and that data I can take. There is no doubt government hospitals and even government sites which are giving this kind of data, that is COVID patients, their addresses, their all the details of COVID patients. Then I determine the sampling procedure. There are various ways of determining sampling. There are some techniques which are called as probability sampling techniques, and some techniques which are called as non-probability sampling techniques. What's the difference between both? Probability sampling techniques are those techniques where each and every respondent has some chance to be selected in sample. Here, investigator has no control. Researcher has no control for drawing the sample. In non-probability sampling, scientific method is not used. There may be biasness, there may be subjectivity. Researcher choose according to his subjectivity. Researcher choose sample according to his subjectivity. In probability sampling, I define that there is some chance. Actually, in some notes, there is that equal chance. Actually, there is not an equal chance of each and every respondent to be selected in sample. It is basically some chance of to be selected in sample. That is, each and every unit get the chance to be selected in sample. It is not necessary that they will get the equal chance. Equal chance they will get only in simple random sampling. Then in next step, we calculate sample size. Then we execute all the what we have defined, that is sampling design. Now, coming to probability sampling techniques. Probability sampling technique.
Excuse me, madam.
Yes.
Madam, some WhatsApp message is coming of yours. It is displaying.
Yes, sir. Yes.
I think it's personal. That's what.
Sir, actually, I have connected to Wi-Fi.
Now clear.
I am on airplane mode, but WhatsApp, that can't be, I think. Maybe I don't know how to switch off the notifications.
Okay. Now it's clear, madam.
I can try. If somebody can help me that how to close the notifications.
No, you can continue, madam. It's not coming now.
Madam, you continue. It's not
Should we
coming.
continue?
Yes, continue, madam, please.
Continue, madam.
Okay. Sir, probability sampling techniques. Probability sampling techniques, when each and every respondent has some chance to be selected in sample. It can be used when the population is finite. Finite, that is, there are countable, there are approachable number of units. If population is infinite, then sampling frame is not possible. Sampling frame is possible only in case of finite population. Because if population is infinite, then list is not available. No? Like number of stars in sky, when we say that, no doubt numbering is started now, but even though we can't provide a complete list of stars, then sampling frame is not available in case of infinite population. So in that population, we can't use probability sampling techniques. For probability sampling techniques, there must be finite population and sampling frame should be available. And here, there is no discretion of researcher. That researcher has no choice. Suppose I like a respondent. I want that respondent should be in my sample, but I have no discretion. I have no power to choose that person in my sample in case of probability sampling techniques, because I have to go by law, I have to go by scientific technique, and in that scientific technique, that person may come or may not come in, may not be selected in my sample. Then next is non-probability sampling techniques. Non-probability sampling techniques where sampling frame is not available. As I already told you that when population is infinite, then sampling frame is not available, and maybe in some other cases sampling frame is not available. And discretion of researcher.
Madam, again you put enter. Now it's okay. Okay, right.
Visible? Slide is visible?
Visible.
Visible.
Okay. Then discretion of researcher. That if researcher wants that a person A should be in his sample, then that person can be selected, because it depends on the choice, subjectivity of researcher. So non-probability sampling techniques, researcher has a lot of power that what respondent he want to select, he can. Clear? Clear?
Yes, madam.
Okay. Now, coming to various types of sampling techniques. Slide is visible?
Visible, madam. Visible.
Okay. There are probability sampling techniques and non-probability sampling techniques. When there is unrestricted sampling, that is, we don't apply any restriction, then it is called as simple random sampling. But in non-probability sampling, or in probability sampling, then when we apply some restrictions, then it is called as complex random sampling in case of probability sampling, and in case of non-probability sampling, it is purposive sampling or quota sampling. Or in unrestricted sampling, in case of non-probability sampling techniques, it is convenience sampling. Now, coming to first technique, that is simple random sampling. It is a probability technique, a sampling technique. That means each and every respondent must have some chance to be selected in sample, and here that chance is equal for each and every individual. Suppose there are 1,000 respondents and I have to select the sample of 100, then each and every respondent will get the equal chance to be selected in my sample. Then in case of complex random sampling techniques, chance of selection is not same. That varies according to method. In case of simple random sampling techniques, there are two types of techniques. One is lottery method and another one is random number tables method. What is lottery method? Lottery method, when it is simple lottery, as we draw slips without any biasness. That is, a blindfolded person draws slips. In lottery method, what we do, no doubt sampling frame should be available, that is complete listing is available. We make slips of each and every respondent, and that slips should be uniform. Only then it will be unbiased. Then a blindfolded person, that is, there should be unbiasedness. Blindfolded person draws various slips, and that slips, how many slips will be withdrawn? What you want to be your sample size. This is the lottery method. Clear? Each unit of population, it is named or numbered and is marked on separate piece of paper, and draw is made without any bias. Clear? Clear?
Yes, madam.
Okay.
Yes, ma'am.
Now coming to next method, that is random number table method. In random number table, there are various random number tables available, like Tippett's table, Fisher and Yates table, Kendall table, Rand Corporation table. Depending upon some are 2 digits, some are 4 digits, some are 3 digits. Random number tables. In random number tables, again we identify each unit of universe, that is sampling frame. A list of sampling units should be available, that is sampling frame. Then we provide serial number, unique code to each and every unit. Is it visible?
Yes, ma'am. Now
Yes.
it is
Okay,
visible.
okay. Identify each and every unit of the universe sampling frame. Then we assign serial number to each unit. That is a unique code to each unit. Then we randomly select any page, row, and column from a random number table. Then we select the units. I have this. This is a part of random number table. It is 5-digit random number table. For using this random number table, that is 5-digit random number table, I must have to assign each and every unit 5-digit code. I have told you that I have to assign a code to each sampling unit. For using this random number table, that is 5-digit random number table, I have to assign 5-digit code to each and every respondent. Suppose in my previous example, there were 1,000 respondents of the Karnataka colleges. Then I have to assign 5-digit number to each and every respondent of the Karnataka colleges. Now, what next I will do? I will do, because in random number table there may be more than one page. Then first of all, I make the slips of all the pages. I randomly draw one page number. Let it be page number 2. In page number 2, there may be many rows and many columns. Here, like here, 4 rows are there, and 8 rows are there, and 4 columns are there. So, in this 8 rows and 4 columns, what I will do, I will randomly draw one row. I will make the slips of 8 row, number 1 to 8 for the rows, and number 1 to 4 for the columns. I will withdraw one slip for the column, and I will withdraw one slip for the row. Suppose slip drawn for the column is 3 and slip drawn for the row is 5. Then I will draw number from the 5th row and 3rd column, that is number is 15370, right? Now I have assigned numbers to all the 1,000 respondents. The respondent which is given the number 15370, I will take that respondent in my sample. Now I will move to next number in this random number table. It is 40164. I may not have given any respondent this number 40164. Then I will leave this. I will move to next number 19660. The respondent which has been assigned this number, that is 19660, I will select that respondent. Another respondent to whom I have assigned the number 16447, I will select that respondent. Clear? And similarly, I will move further. And if I want sample of 100 respondents, until 100 respondents are selected, I will move further and further. This is another random number table. Screen is visible?
Yes, madam. Visible, madam.
Okay. There are 21 columns and 23 rows. Similarly, I will draw one column randomly and one row randomly and select the one identity, one person. Let it be randomly drawn row is 10 and randomly drawn column is 9. Then I will take 3. The respondent who has been assigned number 3, I will select that respondent. Then I will move to next. I will move to next, so on. Clear? Clear?
Yes, madam. Please.
Okay. Now, coming to the merits of simple random sampling.
Madam,
Slide is visible?
No, whenever you now it's visible. Okay.
Visible?
Okay, madam. Okay.
Okay.
Visible, madam.
Okay. If I choose simple random sampling method, then each and every person is given chance, so there is no personal biasness. As I already told you that in probability sampling techniques, there is no personal biasness, because researcher has no discretion to be in the selection of sample. Then it is based on theory of probability, because each and every individual has been given chance. Here it is equal chance. And if this, it can be true representative also. If the population is homogeneous, then it is definitely true representative. If variance is less, even then also it is true representative. Even in the case of heterogeneous population, if we increase the sample size, then it will become true representative. Now, demerits in case of heterogeneous population, if sample size is small, or maybe if sample size is large, even though all the units, they may not, of different characteristics, they may not be selected in your sample. It is quite possible that if there are 1,000 students and students may have different characteristics. Suppose I was talking about IQ level. Then IQ level, some students may have low, some may have medium, and some may have high IQ level. Suppose I have 500 students with high IQ level, 300 students with medium IQ level, and 200 with low IQ level. And I draw a sample of 100. Then each and every student is given equal chance. It may be possible that I have a sample of students who have medium IQ level. All the students selected, they have medium IQ level. It may be possible because I have no discretion. It is randomly withdrawn. Remember that term random in statistics, that differs from term random in English. In English, random, that doesn't mean that each and every person has given equal chance. But in statistics, it means that each and every person has given some chance to be selected in sample. So if all the respondents selected in heterogeneous population, they are of one characteristics, then they will not truly represent the population. It may also possible that if I draw a sample, there are two types of characteristics in my sample, that is low IQ level and high IQ, lower and medium IQ level. But if I look at the population nature, then high IQ level students are maximum. As I told in my example that 500 students, they have high IQ level. So, and in my sample, there is no student of high IQ level. That means it is not truly representative. In heterogeneous population, it may fail. And problem of non-response may be there. When I draw sample, then I have no discretion. Maybe some persons not respond to my questions, not respond to my stimuli. Clear? Clear?
Yes, ma'am. Clear.
Okay. Coming to next sampling type, it is stratified random sampling. Slides, their screen is visible?
Visible.
Visible, madam.
Okay. Okay. Stratified random sampling, it is best method for the heterogeneous population. Heterogeneous population, when units, all the units, they are not of same characteristics. Their characteristics differ. Then what we do, that we divide the heterogeneous population into small homogeneous groups. And each group is called as strata. Each group is called as strata. Stratum is singular and strata we use for groups. And from each stratum, we select sample independently, randomly. Again, if the sample is drawn randomly, then there is no discretion of researcher. There is no biasness. And how we do the stratification? It is done on various characteristics of the population. It may be through administrative groupings. It may be geographical regions. It may be through any other auxiliary variables. Like in my example of students, I can group students according to their IQ level. That is, I can make 3 groups: low IQ level, medium IQ level, and high IQ level. I can classify the persons according to their occupation. That is, self-employed person, service in job persons, retired persons, and maybe students or housewives. I can divide according to that also. That means strata, that is actually basically, that requires a lot of skill. Because strata, all the strata, they should be mutually exclusive and exhaustive. You know the terms mutually exclusive and exhaustive? Do you know the terms mutually exclusive and exhaustive?
No.
Yes, ma'am.
Okay. Mutually exclusive, that means all the strata they should not overlap with each other. That means one respondent should fall in one stratum. And exhaustive means all the respondents should cover in that my classification of stratas. I give you example. When I classify according to occupation, then I have taken the few categories. One is self-employed, then I have taken retired, then I have taken job class, I have taken another, that is housewives or students. Suppose my population that consists of all these 5 categories. So I divided that into these 5 strata, and my population doesn't include any other person with any other occupation. So all the strata are exhaustive because these have covered all the characteristics of population. Suppose I take another category here, that is, let it be professional. Now, if I have to classify the respondent, then self-employed and professional, these are overlapping categories, overlapping groups. A person who is termed as professional, he may be self-employed. It is possible. It is quite possible. Clear?
Yes, ma'am. Yes, ma'am.
Then in that case, my classification of strata, that is not appropriate, that is not accurate, because one respondent that may fall in 2 categories, that will lead to further adverse consequences. Then accurate sampling is not possible. Accurate even stratification is not possible. That's why we say that stratification requires a lot of skills. This is an image which is representing stratified sampling. Here, 3 types of strata are there. First strata, second strata, and then third strata. The whole population that is covered into 3 strata. And there are 3 respondents in first stratum, then 6 in second stratum, and 3 in third stratum. Then randomly I draw 1 respondent. Suppose I have to draw 4 respondents in my sample. Then I will make the slips of 3 respondents in first stratum, that is 1, 10, and 12. These slips should be homogeneous, uniform, and I will draw randomly 1 slip. Random definition will remain same as I have already explained. That is, it will be either through random number tables or through lottery method. Suppose that person withdrawn, that is 10, number 10. Then from other 6 respondents, I will again randomly withdraw 2 respondents, let it be 2 and 8. Then from another stratum of persons, of respondents 3, 5, 5, and 9, I withdraw 1 respondent, let it be number 5. Then my sample that includes this 4 respondents, 2, 8, 10, and 5. Clear? Clear?
Okay, ma'am.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Now, slide is visible?
Yes, ma'am. Now it is visible.
Okay. Stratified sampling, it can be of 2 types. Non-proportionate stratified sampling and proportionate stratified sampling. What does non-proportionate stratified sampling means? That means I draw sample from each and every category, but it is not essential that number of respondents in my sample are in same proportion as in the population. There are 3 categories, A, B, and C. Population sizes 600, 300, and 100. I draw a sample of size 100 and I take sample from each and every category, A, B, and C. And that sample size may be 33 from C, 33 from B, and 34 from A. Total is 100. But it is not in same proportion that of population. Because in population, strata A has 60% of the cases. 600 out of 1000, that means 60%. Stratum B has 300 out of 1000, that is 30% of the cases. Stratum C has 10% of the cases. But in my sample, it is 34% from stratum A, 33% from stratum B, and 33% from stratum C. That means they are not in same proportion as they are in population. Coming to proportionate sampling, stratified sampling. Proportionate stratified sampling, in this proportion of respondents in sample is exactly same that is in population. Like 600 respondents, that is 60% of stratum A in population and 60% in sample also, 60. Then for the stratum B, I have withdrawn 30, that is again 30%, exactly same. And from stratum C, I have drawn 10, that is 10%, exactly same that of the population proportion. Clear?
Madam. Clear.
Clear? Clear?
Yes, madam.
Yes, ma'am. Yes, ma'am.
Okay. Now, this is in the same proportion, but some statisticians and some researchers, they say that accurate samples are those which are not, which should also consider variance in the stratum. What is the size of variance? This slide is visible. Next slide.
Yes, ma'am.
Yes, madam.
Okay. Okay. Now here I have taken into account variance. You can go through a book of research methodology by Professor C.R. Kothari. He has taken this sigma into consideration. For the stratum A, there were 600 respondents, but here variations in data are 5. For the second stratum, variations are 3. For the third stratum, variations are 1. That means highest variations are in first stratum and lowest are in third stratum. Now, I will calculate the weights. How I will calculate the weights? First of all, I will multiply this population size with variance, that is sigma. I will get 600 into 5, 3000. 300 into 3, 900. 100 into 1, 100. That is total of these multiplication population size into sigma. It is 4000. How I will calculate weights? That will be 3000 divided by 4000. 75%. That means 75% of the person should be from stratum A. And for stratum B, it is 900 over 4000. It is 22%. That means for stratum B, from stratum B, I have to withdraw 22% of the respondents in my sample. And from stratum 3, that is C, similarly it is 100 out of 400, it is 3%. It is approximately, I have rounded off the values. And in same proportion, that is of weights, I draw the sample size. That is from 100, I will draw 75 from stratum A, 22 from stratum B, and 3 from the stratum C. Clear? Clear?
Yes, madam. Yes, madam. Yes, madam.
Now if I reverse the variance, see. Now A has minimum variance and C has maximum variance.
Ma'am, it's not visible.
Visible?
Now it's visible.
Yeah, now visible. Now visible.
Okay, okay. If population size is 600 for stratum A, but its variance is 2. I will multiply population size with sigma, method will be same. 1200, then 300 into 3, 900, then 100 into 4, 400. Then I will add all the multiplication values, that is 2500. Then I will calculate weights, that is 1200 over 2500 into 100. It is in percentage. Multiply 100 is, I am also multiplying this ratio by 100. 900 over 2500 into 100, then 400 over 2500 into 100. These are my weights. Clear?
Yes, madam.
Now, what will be sample size? 48% from sample A, 36% from sample B, and 16% from sample C. Clear?
Yes, madam.
Clear?
Yes, it's clear, madam.
Okay. That means, see the difference between both the examples. In first case, I have drawn 75% from the sample A. Here, though the sample size is again, population size is again the highest for the stratum A, but I have drawn only 48 respondents from sample A, from stratum A. 48 respondents from stratum A, because here variance is less. Variance is less means this is homogeneous. Their values are comparatively homogeneous. Their respondents are homogeneous. So I can draw comparatively lesser respondents from this sample. But in third stratum, variance is large. That means there within the stratum, there are still some heterogeneity. And to avoid that heterogeneity, that my sample should be truly representative. So I should draw larger sample size from that very stratum. So I've drawn 16 respondents from that very stratum. Okay, 16 from 100, that is 16% maximum in all the 3 stratum. Clear?
Yes, madam.
Clear? Then it has own its merits. First, it can be used in case of heterogeneous population, as I explained, that each and every step that is to divide the heterogeneous population into homogeneous groups. Then it definitely it is true representative, because I have divided the heterogeneous population into further small groups, and I have drawn the sample from that very small groups through random sampling. And that random sampling, that is again based on the law of probability. So it is based on theory of probability. What are the demerits? Definitely it is complex. It requires a lot of skills, and definitely entire information about the population must be known. Only then you can formulate this data. If information about population is not known, then data cannot be formulated. Clear?
Yes, madam.
Okay. Then coming to next technique, that is systematic sampling. In systematic sampling, what we do, that we arrange the whole sampling frame and assign numbers to them, and then we draw sampling units at equal intervals. What is how we determine that interval? It is
Madam,
basically
not visible. Not visible. The slide. Yeah, coming.
Visible.
Yes, 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 madam.
Okay. All the items in sampling frame, they are arranged, number, and then sample is drawn. Each unit is drawn at equal interval. And how we determine this equal interval? Interval is determined by dividing the size of population with size of sample. As in my case, there were 1,000 students, and I have to draw the sample of 100. And what will be the interval? It will be 1,000 divided by 100, that is 10. From first 10 numbers, that is, I will make the first slips of first 10 respondents and draw one slip randomly from that very 10. Let it be number 4. Then all other respondents will be selected as 4 plus 10, 14, 4 plus 20, 24, 4 plus 30, 34, 44, so on, till I achieve 994. All the respondents at specific interval are drawn in my sample. Clear? Clear?
Yes, madam.
This is the image which is representing systematic sampling. Here the interval is 3. Slide is visible?
Yes, ma'am.
Here the interval is 3. Every third respondent that is selected in my sample. It is blue in color here in image to distinguish it from other respondents. So if there are total 10 respondents, I have drawn 3 respondents at equal interval. First is third one, then 6th, then 9th. This is the another example. Here there are 20 respondents. I have to draw the sample of 5. Then I will divide 20 by 5. Interval will be 4. And from first 4 respondents, I will draw sample one slip. Let it be 2. Then another respondent in my sample. That will be 2 plus 4, that is 6. 6 plus 4, that is 10. Then 10 plus 4, 14. Then 14 plus 4, 18. Right? Clear?
Yes, madam.
5 respondents have been selected. Now, merits. Of course, it is economical, and first unit that is drawn randomly, so it is based on theory of probability also. Now, what are the demerits? Demerits of systematic sampling, it is worst case can be in case of periodicity. Do you know what the periodicity is?
No, ma'am.
No. Oh, okay. I think all of you must know about periodic tables. You must have studied that in your 9th or 10th, periodic tables. Modern periodic table, Mendeleev periodic table.
Yes, madam.
Do you know that?
Yes, madam.
Yes,
Periodic
ma'am. Yes.
tables.
Okay. Then how all the elements, they are arranged in periodic table. They are arranged according to their valency. That is according to their unique characteristics. If I talk about modern periodic table, then first column that contains all the metals, and last column they contains noble gases, and second last they contains known metals. And if I draw the sample at equal interval, actually in first 2 rows it is at second column, and in some rows it is at 8th column. If I draw every 8th item, then I will select a sample of all the noble gases. That means my sample, if there is periodicity, then my sample that will constitute all the units of similar characteristics. They will be homogeneous. They will not truly represent the population. I will take another example. As I have to take the sample of 100 students from the 1,000 students, and I have arranged the data in such a way that at every 10th level, student is meritorious. Suppose high IQ level, very high IQ level, they have been assigned number 1, then 11, then 21, then 31, then 41, then 51, so on. And high IQ level, they are assigned number 2, then 20, then 12, then 22, then 32, then 42, then 52, so on. And third category, that is, let it be low high IQ level, or I take the case of medium IQ, high medium, then low medium. I categorize this as, and I arrange them at same intervals. Then if I draw the sample through systematic sampling, then all the units that will be selected in my sample, they will be of same practices. They will be of same IQ level. And then my sample will be the worst sample. It will not truly represent the population. Clear? Clear?
Yes, ma'am.
Okay. Now, coming towards the next sampling technique, that is cluster sampling techniques. When here also population is divided into subgroups that are called as clusters, and we randomly draw the cluster and randomly draw the sample from that very cluster. You must have heard about during the elections, you are given, you have to go for the vote in area Jalandhar 1 or Jalandhar 2. If I talk about Jalandhar, similarly, I think there must be some ordering in Karnataka also, that Karnataka, in Mysore also, that Mysore 1, Mysore 2, Mysore 3. Some divisions may be there. And these divisions, they may be called as clusters. When I draw a sample, then I draw one cluster from randomly draw clusters. How many clusters I need in my sample, that depends. And then I randomly draw a sample from that very cluster. Now, there is slide is visible?
Yes, madam. Yes,
slide is visible?
Cluster sampling, visible.
Is slide visible? Am I audible?
Yes, madam. Yes, madam.
Yes, ma'am.
Okay. Here, there are some clusters. 5 clusters are there. All the units in cluster, they are sampled. And we have randomly withdrawn 2 clusters. That is, one cluster they are red, rounded with red mark. I have selected that clusters, and if I want, that depends. We can survey each and every unit of that cluster, or further we can take random sample from that very cluster, and these clusters are also randomly selected. Now, here the population, that is natural population within the cluster. I have not grouped the population within this cluster according to their characteristics. This is the difference between the stratified and cluster sampling. In stratified sampling, we group the data deliberately into the homogeneous subgroups. But in this case, I divide the whole population into groups, but that groups are natural groups. Within the group, it is not essential that all the units are homogeneous. Clear? Clear?
Yes, ma'am. Yes.
Okay. Then next is multi-stage sampling. Slide is visible, I think.
Yes, ma'am. It's visible.
Okay. In multi-stage sampling is used when population size is very large, and population is divided into clusters and stages, and sometimes in strata also, and sample is taken from that very stage through random sampling. I have taken this image, and this image here, is it visible?
Yes, madam, visible.
Okay, okay. This first row of circles, it represents the clusters. And each cluster with homogeneous characteristics, I have selected. It form the one strata. It is given in one rectangle in second stage. 159, it is one stratum. 26, it is in the another stratum. Color represent different characteristic. 48, then 3, 7, 10. And from each stratum, I randomly select one cluster. Let it be 1 from 1 and 9 from the first stratum, 6 from the second stratum, 4 from the third stratum, 7 and 10 from the third stratum. And from each cluster, I again randomly select all the respondents, and stars are the respondents which I have selected. From the first and ninth, I have selected 2 from each of the cluster, and this forms my sample. Okay, there are total 12 respondents. All right, I think image is clear to you. I take example. Suppose I have to draw 100 farmers from all over India. Now, all over data of farmers for all over India, that is very large. What will I do? I will divide the whole data, whole country into different clusters. Suppose I divide the clusters, I take the states in form of clusters. Now, different states, they have different agriculture dominance, level of agriculture development. Now I further form this strata. I will take the states which are highly developed in agriculture sector in one stratum, which are very less developed in agriculture sector in other stratum, and similarly I divide all other states in different categories. Let it be very highly developed agriculture sector, very less developed agriculture sector, then medium agriculture development. I divide the whole states in this form. This is called as strata. Clear ho gaya? I think clear.
Yes, ma'am. It's clear.
Now from like in first stratum, that is highly developed agriculture states, Punjab will be there, Haryana will be there, Maharashtra will be there. Similar other states. I will draw any 2 states. Similarly, from the other category, I will draw any 2 states. From the other category, I will draw any 2 states. Any here is through random sampling. Any means through random sampling. Any doesn't mean my discretion is there. I have no choice in probability sampling techniques for selecting a sample. And after selecting this states, randomly selecting the states. I will randomly select, I will make the list of all the farmers. I will take the list of all the farmers. Then I will randomly select any two farmers from each state. I have to select the sample of 100 farmers. I can further divide it into districts also. I have selected, let it be 5 states randomly. Then I will take, let it be 4 districts randomly from each state. Then I will have 20 districts, and I can take further 5 farmers from each districts. Then I will have total 100 of farmers. This is the multi-stage sampling. Clear? Clear?
Yes, ma'am.
Okay. Then multi-stage sampling, it has merits that complete listing is not necessary, because I will first take the states, then make the statum for that, make the stata for that very states. Then I will select few states, and the states which I have selected, I will make the list of districts of that very states. Then I will select the districts. Which districts I have selected, I will make the list of farmers of that very districts only. So no complete listing is required. Again, it is based on theory of probability, that all the sample that is drawn scientifically according to law of probability, and there is no biasness. And but if the areas are uniform, non-uniform, then maybe stata can't be formed. All the states, they are of different characteristics. Then stratification is not possible. In that case, it may not have good results. You know that all the NSSO, earlier NSSO, it used this technique, multi-stage random sampling technique, for collecting the sample. Now, in probability sampling techniques, we can also classify sampling as sampling with replacement and sampling without replacement. Suppose there is a population of 7 people, and I have to draw a sample of 2. What does sampling with replacement means? If I draw a first unit and I replace back it in population, and again I draw a second unit, that means first unit which has been selected once has equal chance, has again the chance to be selecting second time. Here there are 7 persons in population, and I have to select 2 persons. Then it may be possible that John is selected twice. It is quite possible that John and Jack is selected, then John and Q is selected, Jack and Tina is selected, and so on. There will be a number of cases which can be formulated here. As I have to select 2 respondents, and there will be cases 7 here, that is 49 cases will be total there. And what will be the probability? It will be John as 1/7 in first case and 1/7 in second case. It will be 0.02. Similarly, Jack, similarly Q, all have probability, double probability. It is once they will be selected once, then they are replaced back, and there is chance that they will be selected again in your sample. Clear? Clear? Sampling
Yes,
with
ma'am.
replacement
Yes,
is clear.
ma'am. Yes, ma'am. Yes.
Okay,
Madam.
okay. Now coming to sampling without replacement.
Madam, Sellu madam.
Yes.
About 15 minutes. So you can cover the non-random, non-probability sampling for 10 minutes, and 5 minutes the errors you can complete.
Okay, non-probability sampling and 5 minutes for questions, right?
Error sampling.
Okay, sir. Okay. So then I should skip this sampling without replacement.
Just finish off, madam. Finish off.
Okay. Sampling without replacement. For this, I have to select the sample. If I select the unit in my first row, then that I will not replace back. That means that unit will not be given again chance to be selected in the sample. Then coming to non-probability sampling techniques, there are various non-probability sampling techniques like convenience sampling, purposive sampling, then quota sampling, then snowball sampling. Convenience sampling, it is very simple. Name clears its characteristics, that I have to select a sample which is convenient to me. Suppose I have to select the 100 students, then I will select which are easily approachable to me. I will select the 100 students from my own college, from my own class. It is the convenience sampling. Obviously, it will save my resources, it will save time, labor, finance, but it is not based on theory of probability, because my own discretion applies there. Researchers' biasness is there, so it is less accurate, not a truly representative. Then next is purposive sampling. Purposive sampling, here for a defined purpose I draw a sample. It is a deliberate sampling. Suppose I want that my student should participate in quiz competition and win there. My student should participate in quiz competition and win there. If I draw through a random sampling, then maybe student selected is not good in general knowledge. Suppose I want my student should participate in dance competition and win there. Then if I select through random sampling, that maybe that student is not good at dance, levels of dance. So I will apply my own judgment. I will select a student who is good at dance and select that in my sample. It is a subjective method. Depends on my subjectivity. There may be partiality. There may be 4 students who are good at dance, but I select only 1. Biasness may be there. So it is not true that it is not unbiased, but it is definitely, it will serve my purpose. Non-response will not be there. Data will definitely be economical, because there is no need to complete listing of all the items. I have similarly selected the item according to my purpose. Then demerits, it is not based on theory of probability. Biasness is there. Partiality can be there. Clear? Clear?
Yes, ma'am. Yes, ma'am.
Should I move to next?
Yes, ma'am.
Okay. Then slide is visible. It is quota sampling. It is like stratified sampling, but the difference is that here groups are formed, but the samples drawn from that very groups, that is according to the personal choice of investigator. Here, random sampling is not applied. It is generally used in public opinion surveys, like reporters, if they have to interview some persons. Suppose I have to take the interview for the budget. I will make different quotas, that I will take different categories, different groups. Like I will take housewives for the budget interview. I will take a businessman for the budget interview. I will take maybe take some finance persons for the budget interview. I will take agriculture person for the budget interview. And from that very quota, maybe quota number is fixed, that I have to select 2 farmers. I have to select 2 persons who are retired. I have to select 5 persons from job. And that, but it is my discretion that which person I select. I will not choose random sampling. That is my discretion, that which person I have to select in my sample. And no doubt it requires a lot of skills, and reliable if used with proper skills. And it is applicable in public opinion surveys, as I already told you. But again, demerit is personal biasness is there. The next is snowball sampling. You all know that why it is named as snowball sampling, because in this sampling technique, we draw a sample like when we don't know the exact sampling frame, and respondents, they want to hide their characteristics. Suppose I have to select the data sample for HIV patients, then it is quite possible that person will not disclose that he is HIV patient. Then I will first select one person. I will search out one person. If that one person is searched out, then I will ask that person whether you can refer any other person who is HIV positive. Suppose he referred further 2 persons. Then I will further ask that 2 persons to refer more persons who are HIV positive. Similarly, my sample size will goes on increasing. Why it is called snowball? As the snow, if we take the ice ball and when we rotate it on further snow, more snow particles attached with it, and its size goes on bigger and bigger. Similarly, this sampling technique. I will select one person, and from that one person, further reference of 2 persons is taken, then further more references are taken, and my sample size that goes on increasing. Clear? Clear?
Yes, ma'am.
Yes, ma'am. Yes.
So it is also called as referral sampling. रेफरल सैम्पलिंग इसको कहते हैं, चेन सैम्पलिंग भी कहते हैं इसको. हाँ जी, next, where the next slide is visible?
Yes, madam. Visible.
Yes.
Okay, okay. I will take 3 minutes more. After that, we will interact. Then sample size. How will we select sample size? That depends on various features. I will skip this. What is population size? I will directly come to this. If population is infinite, then sample size formula is this: C square sigma square over E square. C is critical value of normal distribution. That is, level of significance. Generally, we take it as 5%, and C that is taken as 1.96 for the Z test. Sigma is standard deviation, and it is taken from the past experience, or it can be calculated mathematically also. And E is the margin of error. What does margin of error means? How much error is acceptable? That is how much difference between the sample and that is statistic and parameter. That is sample constant and population constant is acceptable. Look at the formula. If E is 0, then if I want that there is precision, there's 100% precision, there must be accuracy, then sample size should be infinite. That means larger the sample size, lesser will be the error. If I want that sigma is small, that is sigma is 0, that is homogeneous population, then small sample size will be sufficient. Only one respondent will be sufficient to represent the whole population. Because all the units are homogeneous, then there is no need to take more units. Only one unit I can inquire, and that will represent the whole population. Clear? I have taken this example, C 1.96, sigma 0.5, and margin of error, that is 0.05. I have substituted the values, then sample size is 384 in case of infinite population. For finite population, we put the restriction of population size. Formula is n C square standard deviation square, C square standard deviation square plus n minus 1 E square. And if I take the values, then this will be the sample size, 357. 357 will be my sample size. For infinite sample, it will be more as compared to finite population. Error, I skip this for now. We can interact further. Should I wind up here?
No, madam, please.
Yeah.
You can continue.
Madam.
I can
Madam,
continue
madam.
with sampling errors and non-sampling errors.
Please,
Yeah,
please.
yes, madam. 5 minutes I can complete, madam, because
Okay,
the
okay.
sampling should end
Any
with,
query, if anybody wants to ask anything, you are most welcome. Or should I continue if there is no query?
Madam.
Please continue, madam. Continue.
Continue. Okay.
Madam, I hope you need some more 10 minutes, madam.
No, sir. I will wind up within 5 minutes. I will definitely follow your time rule.
Okay, no, madam. If any further
Okay.
explanations you want to share with the participants, another plus 5 minutes you can, madam. Because
Okay, sir. Okay. Fine.
Please.
What are sampling errors? Actually, basically, we divide the errors into 2 categories: sampling errors and non-sampling errors. What is error? It is the difference between inferences drawn about the population from the sample and result of census. That is difference between the sample constant and population constant. That is difference between the statistic and parameter. Population constant, they are termed as parameter P, population P parameter, and sample constant, they are termed as statistics. S sample, S statistic. These are the terminologies used for sample constant and population constant. The difference between them, that is parameter and statistic, that is called as not actually statistic and parameter, it is the inferences about the population from that very statistic and parameter. Difference between these two, this is called as sampling error. This is called as error. This is called as error. And what is sampling error? It is error due to selection of incorrect sampling technique. कि अगर आप, if you choose incorrect sampling technique, then there must be error. Sample will not be true representative, then there will be error. This type of error is called as sampling error. And it can be increased only by increasing the size of sample. Mainly, I will say mainly by increasing the sample size. There are some other cases also, as I already explained to you, that it can be removed by stratification, by effective enumeration. Pre-testing also result in better choice of technique. Then if I choose appropriate technique, definitely sampling error will remove. Then non-sampling error. This is not due to wrong choice of sampling technique, rather due to some other factors. There may be error in calculations, that is processing errors. There may be, it may be possible that if I inquire any respondent, that respondent may not answer accurately. They may hide the truth. It is quite possible that I have overloaded the respondent with so many queries. He may not be able to handle all the queries. It is possible that there is lack of awareness, there is lack of knowledge. Respondents do not know what exactly required is. This is quite possible that concept is misunderstood. This is possible that measurement unit, that is questionnaire, is wrongly formulated. All these kind of errors are non-sampling errors. All these kind of errors, these are non-sampling errors. And non-sampling errors can be removed by taking more cautions, more precautions. By taking sample, I will say that non-sampling errors can be reduced. Because as the larger the size, non-sampling errors may be more. There may be more errors in processing and other things.
Madam, slide is not visible, madam.
That
Yeah,
is,
now visible,
okay,
madam.
Okay. That is all from my side. I wind up here.
No, madam, please, you can finish, madam. Within another 5 minutes, you can finish, madam.
I wind up here. Now I keep it open for all the participants. They can discuss anything.
Yes, madam. No, please, you can.
Yeah, madam, with regard
Yes.
to controlling the non-sampling errors,
Right.
cross-checking and quarterly feedback reports and pilot survey, and apart
Yes.
from that, effective pre-testing, effective enumeration, specific selection of the problem, systematic documentation, controlling the methodological bias. So plenty of methods are there to
Yes,
correct
sir.
or reduce the sampling errors. Thank you, madam.
Yes, sir. Yes, sir. Definitely, sir. There are so many, actually all the methods which lead to correct choice of sampling technique, they will definitely help in removing or reducing the sampling error.
Thank you, madam. Participants, if you want to ask any question, you can actually. Most of the questions they asked in the chat box, and we have answered it, madam. If there directly anybody wants to interact with madam, you can interact. 5 minutes time.
Okay.
Yeah, participants, any questions you are having? Madam, I have a question.
Yes, sir.
Madam, in calculating the sample size,
Right.
the marginal error is 0.05, take an example. Is it varying or it's a constant error size, madam?
Sir, no. Actually, margin error, that depends on the, I skipped that slide, that depends on the nature of data.
Okay.
That depends on the nature of data, whether it is categorical data or I am coming to that side. If
Yes,
it is continuous data or categorical data, that depend. Slide is visible.
Yes, madam. Now it's visible, madam.
Generally, as a statistician say, they say that for categorical data it is generally 5%, and for continuous data we take it generally as 3%.
Okay, madam. Okay, great.
Okay.
Yes, madam.
Any other question?
Madam, any thumb rule while deciding the sample size? Many times, as many
right. Definitely. Actually, according to different statistical techniques, we use different thumb rules. Generally, it is we take sample size for that is for one variable. We take 10 to 20 units of sample. It is the basically thumb rule that we use for one unit for one variable. Suppose I have 5 variables in my study, then I must have at least 50 to 100 units in my sample.
So it's 1:10 format, madam.
One is to you can say 1:10. It is actually 10 to 20 times.
Okay, madam.
It may be 1:20 also. 10 to 20 times.
Okay, madam. And most of the times,
as in sorry, sir, I'm
continue, madam.
if I talk about factor analysis, in factor analysis we take that there must be at least 10 respondents for accurate results. In regression, sometimes we say that for one independent variable there must be 50 that is 50 units, 50 sampling units, 50 values, responding values. Then we can fit accurate regression.
Okay, madam. Madam, and regarding with respect to the sample size, suppose the students are we are doing a study in the HR related topic, madam. So students will be doing a project in the HR department, and on that time, normally in the HR department in organization, the sample size will be less. Means most of the time they'll go for the census study. Is it right to select the census, or again we should stick on to the sampling method?
No. That depends. If the size, I already told you, if size of population is less, then you can use census method. There is no harm in using census method. But if the size of population is large or you have lesser resources, there are so many factors which affect, then you must use the sampling method.
Great, madam. And on my end, last question, madam. See, what should be the minimum sample size? Because many times, as if the sample size is less, means error will be high. So, what should be the optimal sample size as any project, even a student's project or a researcher project, they should maintain, madam?
Okay. Actually, I already told you that what's the criteria of determining the sample size. That depends. Actually, there is no fixed limit that this should be the sample size.
Okay.
But I have told you the criteria. That depends on the nature of population. That depends on the accuracy you required. That depends on the nature of population. Suppose if population is homogeneous, then I told you that only 1 unit of sample will suffice. That will be sufficient. There is no need to go to larger sample size. That depends on the variability in the data. If there is no variability in the data, then there is no need to take more and more units to represent the population. But if there is a lot of variability in the data, then our sample size should be large. Larger the sample size, more accurate the results will be. And similarly, no doubt many other factors also affect. Like for the PhD students, they have to, though the population are heterogeneous many times, but they have to cover their
representation of all
whole research work within a stipulated time period. So they have to consider that in mind also. And feasibility, that is also very much essential in that. Then we always use that mathematical formula for using the sample size, for calculating the sample size. And that formula, generally sample size that is drawn from that very formula, we should take little bit more from that very, than that. Suppose I take 384, then I must draw 415 or 425, because there may be a problem of non-response also.
Yes, ma'am. And
Yes.
most of the research scholars, they are doing, when in their title they try to cover the entire state. Means they are doing a PhD project for the entire, representing the entire state, or sometimes two states, or sometimes the country level. So in
Yes.
that time, how they, what should be the optimal sample size? Because sample size is only representing the entire population.
Sir, there is a
Yes, yes, sir.
sir, there is a table. There is a checker.
Yes,
There is
sir.
a table, sir.
Mhm.
Say if the sample is very small, you have to take all as the sample. Say for example, if it is 10, 25, you have to take all the samples.
Mhm.
If it is 100, it will be 80%. If it is 500, it says that 144. If it is 1 lakh, it says that 344. If it is
Right,
10
right.
lakhs, if it is 10 lakhs, it says that some 854. Like that, it goes on, sir. There is a table. I'll
Right.
just read it.
Can you get this table, sir?
Yes,
sir.
yes, sir. It is available. It is available
Yeah.
even online also.
Madam, any
Sir,
sources? Sources can you mention? Can you tell to the participants, madam, so
Yeah,
that
yeah.
they can
Okay,
get
I will
more
send you
clarity?
the source, sir. I will send you the link.
Yes,
Even
ma'am.
I think Professor B. Gopal Singh also can also share that.
Yes, ma'am. Yes, ma'am. Madam, please say your video. You are not visible in the video. Please
Yes.
switch on
Okay,
the video.
okay, sir. Just a minute, sir. Just a minute. Sir, now is this visible now?
Yes,
Okay,
ma'am.
okay,
Yes,
okay.
yes.
Okay, sir.
Somsekhar sir, you can thank madam.
Yes. Dear participants, now I would will come to the end of the session, and it's a really worthful session, madam. The time is almost, we started around 10:30, and it's almost 12:10. It's almost 1
Yes,
hour 40 minutes. So I even though I with respect to sampling designs, but today your sessions are in detail about the sampling techniques, sampling methods, and the reasons for go for sampling. And actually, I'm impressed with the because in each sampling technique, normally we deal with just the theory or with some examples, but you scientifically explain that why it was taken and with respect to their merits and demerits. That was very excellent, madam. And I think I'll appreciate your sessions from all the participants. Thank you very much,
Thank
madam.
you, sir. Thank you very much, sir. Thank you. My pleasure to interact with you also. Interact with all the participants. Thank you very much.
Thank you,
Thank you,
madam.
madam.
Ma'am, thank you so
I thank
much.
the.
Could we have your email address if possible, if you could share it with
Yes,
us?
yes, sir. It is shalubatra@gmail.com. My name @gmail.com.
Madam, put it on the chat box, madam.
Thank you.
Okay, I will put it in the chat box.
Dear participants, here the feedback link is already shared. Please submit the feedback. And I'm thankful to the management and beloved HOD Dr. P.S. Balaji Rao and all the participants for joining the session. Any updations or suggestions or improvements, please feel free to share with us. And also, once again, I'm thanks to the madam for joining the sessions. Madam, we'll have continuous interactions, and as Vidyavarta College of Engineering is well known for its research center, and usually we organize a series of the research workshops. So I expect you should be a resource person in our future workshops also, madam.
Sure, sir. Sure.
Thank you very much, madam. Thank you.
That will be my pleasure, sir.
Thank you.
Okay, sir.
And also
Thank you,
thankful
ma'am.
to
Thank you.
Gopal Singh sir also. Thank you, sir.
Okay, sir.
Thank you.
Thank you. Dear participants, please fill the feedback forum. I'm sharing once again the link. Anybody having doubt or anything you want to discuss, you can. And today afternoon at 3 o'clock, we'll be having the hands-on session on the non-parametric test. Yesterday, you all discussed with the parametric test using SPSS. And today, we are going to deal with the non-parametric test by Dr. Narayan Swamy. Sharply at 3 o'clock, 3 to 4:30. We'll send the Excel files for working. Please go through that and be ready with the SPSS in your laptop. So the sessions will be more interesting. Yes, Madam Sneha, yes, we'll give the list of the research books, okay, which are very good in content. And even we'll collect from the resource persons also, because as you've already gone through the sessions, so I hope that will help you a lot in understanding or getting the informations. Yes, day 1 and day 3 session, one recording has not been sent. Kindly send it. Thank you. Yes, we are already sharing to all. So if anybody is not getting our the resources, please drop in our research methodology, the WhatsApp group what we created. Definitely, if any individually we didn't got, so we'll send you once again. Yes, thank you all. Miss Sohini Bhattacharya, madam, it's a WhatsApp group. It is open to all. Okay. Unless you can mail also. Yeah, only admins can chat. Okay. Okay, madam. We'll consider, and you can mail to us also. No issue, madam. I request all the participants to fill the feedback forum.